have studied classes, I guess, the half wave rectifier with LS, without LS, and with LS. Question. What is answer? Can you hear me?
Yes, sir.
What is LS? What is LS? I told that we have considered the half wave rectifier without LS and with LS. What is LS? Nobody can answer this question. Hello. Hello. Can you hear me? Can you hear me? You hear me? Okay, then you say we forgot. We cannot answer. Hello? Nobody knows what is LS? What the hell you do then at home? Power electronics is the most easy subject or easiest subject. If you cannot answer this question that we have already covered, then what is the point of doing the class? Did we cover this circuit? Are you third year students with fifth semester? Hello? 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 Do you hear me, please?
Yes, sir.
Yes. So did we cover this circuit before in the previous class? This one? Yes or not? Oh Allah. I'll not take class, I am telling you. Did we do this class? So how many students are there? 19 students are here.
Actually, we have a quiz after this class. Maybe they are busy with that quiz.
Okay, good. But 20 students have come. So I am asking you whether I have completed that one, that circuit. This one.
You can continue, sir.
Yes, sir. We covered it, sir.
So you can tell me that. Here, look here. We did not consider any source inductance. So LS is the source inductance. I'm not asking anything. I'm just continuing. LS is the source inductance. For this circuit, LS was 0. Then we got that output voltage VD was 0.45 Vs minus omega Ls ID divided by root 2 Vs. And also the voltage, the current, sorry, the delay angle, the commutation angle U, commutation angle U is 0 here. When we shall consider Ls equal to not 0, then the circuit becomes this is your load, and this is the load voltage. This is D2, this is your Q1, this is your Ls. So Vs equal to root 2 Vs sine of omega t, and then this is your Is, and this will be your VLS, and this is your ID. And for this case, we got the previous case actually, yeah, whatever that time Ls was 0. Previous case I write this one, right? 4 Vs minus omega Ls ID divided by root 2 Vs. My previous case when Ls was 0, so it should be 0.45 Vs without Ls. But for Ls equal to not 0, finite value, this will be a video. Vd should be your 0.45 Vs minus omega Ls ID divided by root 2 Vd, because Ls will have a finite value. And the cosine U, will be 1 minus omega Ls ID divided by root 2 V. This will be your price pi. I'm very sorry. This will be price pi, and this will be your cosine U. We have already covered all these things in our previous class, last class. If you go and see the equation number that we have got, this one will be 5.26, and this is 5.23. This is cosine U will be 5.22, and the Vd equal to 0.45 Vs minus omega Ls ID divided by 2 pi. The output average value of the output voltage, that was your 5.26. And then we have also considered for the non-zero value of the Vs, if Vs is not sinusoidal, like this is your pi, this is your twice pi, this is your omega t, and this is your Vs. So instead of sinusoidal, how we can find out the cosine U and output voltage Vd? We have already done that thing in our previous class. Now the question is whether you can remember it or not. Hello. Hello. Hello.
Yes, sir, we can hear you.
Okay, so did we cover all these things? Did we in the last class, did we cover all these things? You forgot.
Yes, sir.
Okay. It's up to you whether you remember or not. For full wave rectifier, bridge rectifier, of course, bridge rectifier. So this is your circuit. So this is your sinusoidal root 2 Vs sine of omega t. I think because of your preparation for your next quiz, you are not attentive in this class, right?
Yes, sir. I think most of the students are studying.
And those who are also log in, you are also studying the quiz. Which quiz you have now? Rule Amin sir?
No, sir. 5 habits are electronic quiz.
So that should not be very tough. Why should we give a lot of time for this one? Okay, when LS equal to 0, then VD0 should be your 0.9 Vs because this is full wave rectifier. Output voltage will be like this. And when will be the quiz?
Sir, in the evening.
In the evening, we have a lot of time. So now if you don't do this class, then you will miss a lot of things also. So if LS is 0, you will get this one, and if LS is equal to the U, the commutation angle will be 0. When LS equal to not 0, then your VD will be your 0.9 Vs minus 2 omega LSID divided by pi. And the expression of cosine U will be your 1 minus 2 omega LSID divided by root 2 Vs, that is your 5.32. We have covered until this one. Now, I am just today I am introducing the new circuit 5. And I am finishing it very quickly. Constant, but I am very upset that you are not serious, and you have to face the consequence for this one. I'll make the question so tough, then you will understand what is the meaning not to attending the class. So you will just convey this message to your friends. Every class is important. So instead of putting the load voltage, load current as a constant, now we are assuming that load voltage load is the constant voltage. Previously it was constant current, now it is constant voltage. So this is your D1, this is your D2, this is your D3, and this is your D4. And here we will consider finite source inductance. So then the current will be your ID. That will be your load current. So we shall study this circuit right now. Okay, now so people can normally what they do, they just replace this circuit as equivalent circuit. This is Vs. because positive half cycle and negative half cycle you will get the rectified wave. So that this is this inductance LS, and all that this diode will be just represents all the diode. This D1 and D2 will be for the positive half cycle, and this D3 and D4 will conduct for the negative half cycle. And now this is the load side, and this is your VD, and the current will be your ID. Now if we plot that one, suppose we are plotting this is your pi and this is your twice pi, then this is your maximum value if Vs equal to √2 Vs sine of omega t, then the peak value will be √2 Vs. And then we shall consider that √2 Vs, that means the peak value Vm must be equal greater than Vd. Otherwise, the diodes will be reverse bias. Okay, if this is the value of the Vd, that means say suppose this is a battery, we want to charge it, and then so current will start when your Vs, this is your Vs, will cross the Vd. So Vd is for reverse biasing this D1, D3, D4. Or here from here, you see that this Vd is reverse biasing this diode. So if this Vs is greater than Vd, then only current will start flowing. Okay, the current will have that, say, will have the wave shape like this. The starting current will be at omega t equal to theta p. The peak value of the current will be at theta p, and final value of the current will go at theta f. For the next half cycle, we can also consider this kind of situation. Next half cycle, that means negative half cycle. This is pi plus theta b. This is your pi plus theta p, and that will be your pi plus theta f. And that will be the wave shape of your current ID. And here we can see that this is discontinuous. It is not, the current will be 0 until this, then it will be 0, and then it will have, when your Vs crosses the Vd, then current will stop flowing. And the peak value of the current will be at the crossing point of Vs and Vd, because when the current is flowing through your circuit, we see that if we apply the Kirchhoff voltage law, it will be your VL plus Vd. At the crossing point of Vd and Vs, Vs will be equal to Vd. Then from here we can write down VL will be 0. Then Ls di by dt equal to 0. So this will have that when the slope is 0, then VL will be 0. Since VL equal to 0, then the slope will be 0, and slope will be only the peak value. So that is why at the peak value of the current, that will occur when Vs and Vd crosses with each other. Now our target is to find out the expression of theta b, theta b, theta p, and also theta f, and we want to find out ID, the expression of the ID2, and also we can find out the average value of the ID. Average value of the ID. That is our target. Okay, let us try to find it out. Are you listening to me?
Yes, sir.
Yes, sir.
Yes, sir.
So first we want to find out the expression of theta b, beginning of the current. Expression of theta b. Can anyone tell me? We know the equation Vs equal to root 2 Vs sine of omega t. And also we know that at theta b, Vs process Vd. Can anyone tell me how can we find out theta b? Okay. At omega t equal to theta b, your Vs equal to Vd. So we put this one root 2 Vs sine of theta b. Theta b will be then sine inverse 1 root 2 Vs by Vd by root 2 Vs, right? Then number 2, we want to find out theta p. This one, theta p. If you know theta b, what will be the value of theta p by trigonometry? Can anyone tell it? This is your equation 5.34. This theta b equation 5.34. If you know the value of theta b, then what will be the value of theta p? Can anyone tell me, please, quickly?
Sir, 90 plus theta b.
Or pi pi minus theta b. Remember, go back to your intermediate things. If it is pi, if it is theta p, then what will be your theta p by symmetry? Yes. This one will be, is it not, this one will be also theta b? Hello.
Yes.
Then theta p will be pi minus theta b. Am I correct or not?
Yes, sir.
Okay, so this is your equation number 5.35 of your book. Now we have to find out the equation of ID. We want to find the expression of ID. We can use the expression of VL. VL equal to LS dID by dt. And if you apply the KVL here, then that will must be equal to Vs minus Vd. That means root 2 Vs sine of omega t minus Vd. Then LS dID will be your root 2 Vs sine of omega t minus Vd into dt. Yes or not? Then
Yes, sir.
both multiply both sides by omega. Then omega ls did will be your root 2 Vs sine of omega t minus Vd. You can put inside this one. Is it okay? This omega is taking here. Yes. Then the ID, say theta, 1 by omega ls root 2 Vs sine of omega t minus constant Vd within bracket, then we can write down this one. Is it okay?
Yes, sir.
Okay, this is your say equation number 5.37, and from that we can find out the expression of ID. ID theta will be, you have to integrate it. Okay, derivative, let us put this way. Integrate it derivative to theta b2 theta, it will be the theta b2 theta, then 1 omega ls root 2 Vs sine of omega t minus Vd d of omega t. Then what is the current at theta b? Here. Oh, what happened? It has been changed somehow. The figure has been changed. No. Should I make it again? Somehow it has been changed. It moves, the skin moves, and then okay, let me draw it again. Okay, big deal for me to draw it. This is pi, this is twice pi, and this is the PD, and this is your theta B, and this is your theta P, and then that will be your theta F. Pi plus theta B, pi plus theta P, and this will be pi plus theta F. So this is ID we want to find out. So what is the current at theta B?
0.
0. Okay. So here we can put 0. Then we can write down ID theta. Actually, okay, this will be omega t. So you can put ID theta. That will be the final expression will be theta B to theta. Theta B, you have to find out, you know that theta B will already have find out, right? That will be your Vd by root 2 Vs. So if you know Vd, if you know Vs, then you can always find out. Then you have to just integrate it. And then we have to put the value of theta B and theta, let us keep like theta for the general expression. So that is your equation number 5.38 of your book. So you know now the expression of your theta, ID theta, right? Then what will be the average value? Again, that has, oh, that line has been deleted, right? So if you know the expression of ID theta, then what will be the expression of the average value? Suppose the average value will have that wave shape like this, constant ID. What will be this one? We have to find out the area of the ID and divided by the time period, right? So that is your theta B to theta F, your ID theta divided by your pi. This should be the expression of your this is a 5.40 average value of not correct load current. Okay. Now, what we want to do, we did not find theta F, right? What will be the theta F that we need to find? Can you hear me?
Yes, sir.
Yes, sir.
Okay. Because I turn on the fan. Outside of my room, someone is talking. So I turn on the fan so that that talking cannot go to you. That noise. Okay, now we want to find out theta F. We know ID theta will be here. 1 by omega LF, then theta B to theta, then the root 2 ZS sine of omega T minus 3D. D of omega T, we know this equation, right? So you put theta is equal to theta F, theta is equal to theta F. What is the value of ID, theta F? Look here. What is the value of the current at theta F, final value of the current?
Yes.
Zero.
Okay, so you put 0 here. So 0 equal to 1 by omega LF. Then you know theta B, you don't know theta F, but you know rest of the thing. Then from that one you can find out theta F. Okay? This is 5.39 very good. So for this type of circuit, if a battery is connected, so we can find out the output voltage is of course okay, I'm again drawing the equivalent circuit. If you remember, I have already introduced to you. So VD, LF. So voltage is VD, output voltage is constant, and the current ID, we have already found out the expression, and we have to find out the expression of the constant current. We know VD, then we can find out the also the power. And we can find out theta B, theta P, theta B, theta B, theta F, everything is known to you, then we can always play around and design our circuit. Actually, that was my intention. Rest of the, there are some other things. Show you. Can you see the booth? Hello.
Yes, sir.
They have also plotted here the VL. Yeah.
Yes, sir.
This is your VL. VL will be, you know that VL will be nothing but the LF dID by dt. So this slope is positive, so you will get the positive VL, and after the peak value, this slope is negative, so you will get the negative value. And this area A and this area B, that must be equal. This is your theta B, this is your theta P, and this is your theta F. And in the for the negative half cycle, the current is going in the other direction. So if you plot the IS current, then you will get the mirror replica of this type of things like this. So now the slope is here negative, so you will get the negative VL, and the slope is positive, then you will get the positive. This is for the negative half cycle, okay? So you don't worry for that one. And after that, there are some other things that is not for you, like this figure 5.17, rectifier characteristics. You know that the total harmonic distortion, if you plot with respect to the average current with respect to short circuit. What is short circuit current? If you short circuit the battery voltage, then that will be from the circuit, you know that it will be your VS will be your VL. From that one they can find out, and then they plot it and see what is the effect, all these things. So we will discuss all these things, inshallah. If you do postgraduate master's program in IUT, then I'll show you or tell you how it works. So this will not be covered in your syllabus, and there are problems. And with that one, they have used the ORCAD, or what is that software? PSPice software, you can solve a lot of things. Actually, the graduate students, they do that. So after this chapter will be finished, inshallah, we shall start the control rectifier after the Eid. But before that, there will be something that I want to show you. You have to. Okay, just hold on. From the Harun al-Rashid, there is something. Just wait. Okay. Of course, you cannot see it. Can you? Can you see the book? No.
No, sir, not yet.
Not yet. Okay. Can you see it now?
Yes, sir.
Okay, so yeah. Okay, see the index. Sometimes it is difficult to find. To 7. Target it. To find out. This is a bomber. Before that, it should be. I think. Yeah. So this is the 3-phase rectifier. We shall cover it, inshallah. This is in our syllabus. We will do that thing. We have already covered from the Harun al-Rashid this thing. This thing we have covered. 3-phase thing. Multi-phase or 3-phase are in our syllabus, but inshallah that will be covered in the after your Eid vacation. Okay. I'm trying to find out some other thing. If we connect our rectifier for the, say, here. If we connect our rectifier to, can you see the book now? This is the bridge rectifier, the single phase full wave rectifier with RL load. Actually, it is not RL load, rather than it is the motor load. So this is your DC motor armature resistance. This is the DC motor armature inductance, the back EMF. So in the steady state case, we are thinking that. So for the positive half cycle current will go this way. Come back this one. So then, okay. And for the negative half cycle, current will go this way, this way, this way, this way, this way, this way. So similarly, when we consider the highly inductive load, so IS current was like this, if you remember. So for the positive half cycle, you will get that. For the negative half cycle, you will get the current like this, right? But when it is not very highly inductive, rather than inductance and resistance here, so the output current will have that wave shape like this, fluctuating type. This is your load current. It is not exactly DC, rather than there are some ripples, but there will be the average value will be like this. So we can find out the expression of this one. Also, we can find out the what will be the ripple in that one. And if we know that this is the current for the positive half cycle, so IS will be like this for the positive half cycle. But for the negative half cycle, you will get the mirror replica. Mirror replica means that if you put a mirror here, then what you will get, that will be shown like this. You have to please go through this one, but it will not be set in the exam. Okay, so look here. That is the first figure. B is the load current. Second figure is the source current, and then this is for the discontinuous current. If the current is not continuous, and then for the continuous current, we have applied the Kirchhoff voltage law. That means Vs equal to suppose you have that like this. You have this one, and then resistance, inductance, and back EMF. So if you apply the Kirchhoff voltage law, then that will be your, look here, this is the Vs, and this is
Are
the,
you writing something? Sir, we cannot see on the screen.
you cannot see the writing.
No, sir. Like what you are writing, we cannot see. We can see the page of the book.
Okay. Just hold on. Yes, just hold on. Okay. Can you see now?
Yes, sir.
Okay. So like our circuit was the full wave rectifier. I thought you were not listening anything, and also you are not watching anything, because
Sir, we are watching.
We are watching.
good. You think this is your T4. Suppose this is your load. What type of load? I already told you. What type of load it is?
Motor load.
DC motor load. Yes, this is your
DC motor load.
this is resistance, this is the inductance, and this is your back
Back
EMF.
EMF.
If we say write down, okay, I get positive, negative. This one is the mod value. Then we can replace that this circuit by its equivalent circuit. So this current I0 is flowing through it, and then we can write down the Kirchhoff voltage law. So R is L, this is P. So Vs will be this when the current is flowing, right? The sine of omega T, and then RIO plus LVIO by dt plus E. Okay, that has been given here. If you look. Okay, and then
Yes.
you have to solve. You have to find out the solution. Then you know the quadratic equation. How to so not a quadratic differential equation. You have a particular solution as well as you have transient, right? what you call differential equation, you have two solutions, particular solution and another one is called. This is your mathematics. The steady state case is this one, this part and this part. 1 and 2 is the steady state case, this is your transient part. So look here, there is a A1, you have to find out the value of A1. Okay, so there are some condition here. So you have to apply all these condition. And this, with that one, say here, if you look at the condition here, here suppose at omega t equal to pi, I0 equal to TC value of I0, then you submit this one here. This one is the I0 and with omega this is your pi, and then you can find out the value of your A1. And even that in the A1, look here, in the A1, you have another unknown IO. You have to find out this one. So you have to again search for the another boundary condition. Oh, again, it has changed. I don't know. The screen sharing, when it got other than the green color, you cannot see what I am writing. Now it is okay. So can you see it now? Hello.
Yes, sir.
Sir,
Yes.
yes, sir, we can.
So this one, we have to find out the boundary condition, and then with that one, you look at equation number 3.5, 3.15, this one. So the I0 has been found. These are the values which is known to you. And with that one, you again substitute this I0 here. Then you will get the general expression of your I0. So I told you don't need to do it, just look at it, because in the practical life, you have to do this kind of thing. But in your exam, if you need to do it, you will have problem. You understand what I say?
Yes, sir.
So then, if you know IO, then you can find out the RMS value of the diode current and the RMS value of the load current, all these things. Actually, once upon a time, I used to drive it in the class. Then nowadays, my feeling is that you don't need to do it. Just because it's just wastage of time. You can just at room, you should go through it and you should know this is the way we have to find it out. And for the discontinuous,
Look important.
what is your question? Derivation? No, I told you. No. For the exam, important, yes, for your life, but not for your exam.
Okay, sir.
Suppose the current will have like this wave shape. It is not continuous other than discontinuous. If the value of the inductance is less and the value of the resistance is high, then you will not get the current like this. It is continuous current, but you will get the discontinuous current. And for this one, you can also find out the expression of all these things. What I want to tell you that if it is not set in the exam, so I believe that we will never look at it, but it is my duty to inform you that these are the things you should go through it, not for the exam, but for just for your understanding that this is given in Harun Rashid's book. If we need it, then we can always go and study and find it out. You got my point, what I want to say?
Yes.
Okay. So these are the things you do it by yourself. And inshallah, after Eid, we shall meet. And we shall start not the three-phase rectifier. I am planning not the three-phase rectifier. Rather than we shall start the control rectifier that means with SCR for the single phase one. Then after completion of this with LS and without LS, then we shall come back again and then we shall study the three-phase rectifier, direct rectifier without LS and with LS, and three-phase rectifier with the thyristors. Only LS equal to 0, not non-zero value of LS, because that will be very tough. That is my syllabus from my side. Okay. And okay, how many weeks will, when is the time of your final exam?
Sir, from 30 August, I guess.
30th, we have a lot of time. Okay, so because you are already very inattentive in the class and almost 40% students are absent, so no more today. Let me take a